Oh,
Sorry,
good in the proverbial hood.
Yeah, cool. Okay, so so you mentioned a couple of points around how long we're doing it. So I'm going to take you all back in time, a little story back to the early noughties, almost 20 years ago now, when a young, bearded man walks into the technical operations center, and he'd probably had a haircut sometime within the last few months. The technical operations center of an international telco. Is his first day on that particular job, and he sits down next to his supervisor, Spencer. And Spencer hands him a hard disk and a drive bay, tells him to install his preferred version of Unix onto it, because back then that was how hot desking was done. And then when they're done, the two of them would go over the test scripts, which Spencer had been working on to verify new user connections onto a Cisco 10,000 series router. So they never made it to that script, because that was the first time that that young man had ever built and compiled an operating system from scratch. So it didn't quite go according to plan, but it was also his first experience of working with some highly skilled engineers and architects. And as mentioned, doing DevOps things way before DevOps was even a term. That things like configuration management by software, network configuration by software, automation, all of those good things. So fast forward to today, and that young man honed all those skills, tuned them all up, and now runs his own business and has worked on many projects for a lot of large household brands like HSBC, Vodafone, HMRC, which is the UK tax office, but also taking those skills and experiences from the enterprise to help startups launch faster, cheaper, and safer. So as mentioned, my name's Gareth. I'm the principal engineer, architect, and founder at Mesoform. We're a Google Cloud partner, and we've spent the last few years using Terraform to build and maintain Google Cloud for one of the largest banks on the planet. And that work often props up critical infrastructure for the global economy. So there's a few statements or questions that are up on the screen at the moment. As good DevOps engineers implementing best practices with the great technologies like the ones that come out of HashiCorp, I'm sure there's one or two people on the call that have come across questions like this before. There was talks before around enforcing compliance. We want to automate things. We want to add security into our modules. Of course, the answer to all of them is yes, but to do so is going to add logic every time we do so, which brings us to why we're here. As soon as we start adding any sort of logic to our code, we really should be testing it. So just to make sure that people are on board for the right talk, this isn't about testing Terraform the application. That's already well laid out by HashiCorp in the Terraform GitHub repo. It's also not about testing the actual deployments themselves, although there will be a little bit on this later on. It's about unit testing the HCL modules. So those things that we write to deploy infrastructure, but in a way that creates some customization that you or others might want to use again and again. I'm also certain that there's going to be people on the call that know a lot of the terms that are going to come up, but there's bound to be one or two people that don't. I've already mentioned unit tests, so I'm going to cover off some of the concepts and terminology so that everyone knows what I'm referring to. So when we write code, a good practice is to write it in a functional or like manner that allows us to easily test small bite-sized chunks of it. Now, a unit test is one which checks those small pieces of functionality do what we expect of them. And an integration test is about testing the results when combining components together. So, for example, a function may need to do something with a database, and we need to check that when it actually connects to a real instance of that database, wherever that might be, it still works as we expect it to. In the Terraform world, that could be akin to having some very simple implementation of our module and running Terraform apply to some staging environment and make sure that it actually runs successfully. So a plan and a apply, if they both pass, our integration is done. An acceptance test is a bit more of a real usage of the module or set of modules, perhaps, where we have them working all together. We'll have perhaps using more real-like data, or even real data for deploying those modules or deploying that infrastructure. And then maybe we've got some policies around that deployment that make sure that once we deploy it as it is to some test environment, that it looks exactly as we expect it to before we go off and deploy to production. However, anyone that's actually ever done any extensive code testing knows that often it can be quite hard. And this is because writing a function that's as simple as x plus y is simple. And even with human eyes, we can verify that it does what we expect it to. But we need to consider that something may well change on the inputs. The logic within it might need to be changed, but the desired outcome still needs to be the same. Then we've also got to take into consideration that later on, somebody else might be working on that code base. It could be working on a completely different bit of functionality of that code base. They could fat finger your function, and then x plus y becomes x plus u. We want to be able to have a set of tests that we can always run to make sure that we get the expected or maybe even unexpected results. Adding those tests to our code is going to give us greater confidence that it does what we expect it to, making it more reliable, more maintainable. And in addition to all that, a new developer can use those tests when they start working on that same code base. If they're well written, they can start at the tests, and it can be a useful way to get up to speed more quickly with what all of the functionality is doing. Then once we've got all of that good test suite, which gives us a really high confidence in a robust development practice, we can do all the cool things like automating our module releases. And that's going to, in the long term, that small bit of effort we'll put up front is going to reduce our overall workload. We're going to be able to deliver things more quickly. It's going to be a better code base, more robust code base. So our incidents are likely to reduce. And if you've ever been an engineer on call, like I have, it's going to increase the most important metric, the TIB. So there's a few different approaches to how we write tests. Behavior-driven development was talked about on one of the talks earlier. One that comes up quite a bit is test-driven development. This is a concept where before we even touch any functionality of the code, we'll write the test first and write their functionality to meet the requirements of the test. In my experience, I haven't seen that actually happening all that often. What tends to happen, what I see, is that we tend to do what I would call test-driven refactoring, where we perhaps write some naive implementation of that of that function, and then write the test against it and iterate over the functionality and improve on that piece of functionality, always making sure that we meet that test. Now, if we're writing in more flexible and feature-rich languages like Python or Java, they're usually much easier to do testing against because they've got quite powerful frameworks that help us. But in the HCL world, that framework doesn't really exist. So that's kind of what we wanted to put together. So I mentioned earlier on that when we start asking more questions, we start adding more logic into the code. Now you could ask, why would we put that logic into the code? And why would we not put it into something else like Python or Bash and wrap Terraform in some, and in some complex cases where we can't really do it that well in HCL, or particularly HCL2 is much more advanced. We do still do that a little bit, but Terraform, the modules themselves are often our source of truth, often places where we need to write in compliance to or security things to. So any code decisions we like to keep in the same code base wherever possible. And then those modules can be reused in their pure form, and those decisions get reused along with the module. So up on the presentation, up on the screen, this is a snippet of code from a Terraform module, which we've been writing, which adapts YAML-based configuration into Terraform deployments for things like Kubernetes and Google App Engine. And the idea behind it is to maintain consistency in the configuration. So from reading the standard documentation, which is probably written in YAML, many of them are, and deploying then on a developer's laptops all the way through to the DevOps engineers, building and maintaining the production deployment process with Terraform. So these are two functions which return a map. And now if we expand on that and we assume that there's many more of these, which in that particular module there is, and over time, they've had to change for some reason, which again, in that particular module they have, we want to be able to make sure that we can test them. So how do we go about testing our code in a way that allows us to unit test those functions? First of all, whenever it's possible to, we put any of the logic into the locals block. So we don't write them into the resource blocks if we can help it. And those locals blocks live in their own file. And let's call it something underscore locals.tf. And we leave the resource blocks and other blocks into other files and set them to take those local values whenever that logic is needed. So for example, here on line 52, we're taking a constructed complex map and feeding it into the for each block, the for each loop for our Google Cloud Run service resource. If we just have a look at the code again, so we can perhaps understand the logic a bit more and get a feel for what we're doing. Highlighted is the loading of the actual module of the YAML file, which we talked about, checks that it's on disk, and then uses YAML decode to load it into a variable, which then on all the different cases below, we're using variations of that map to be able to extract and give ourselves some new values. We've got lookups, we've got merges, we've got conditions down here that were a requirement for us to be able to create the module as we need it. This is one of those YAML files. We've got some keys for our Google project ID, whether we want to create the project to start with. We took the idea that if there's any times where we're deploying multiple apps to Google App Engine, we might have some common keys. So we set that so we don't have to keep repeating ourselves. And then we get into the actual specification for the app itself. And all of these are exactly the same as what you'd expect from deploying an app to Google App Engine. Same for Kubernetes. We've got 3 or 4 apps defined for deploying to Kubernetes. This particular app defines an ingress, it defines a stateful set, and all the keys beneath that are the same as, or if not as close as possible to the actual key that you'd expect for a normal Kubernetes deployment. Once we've got all our logic and our input data, we need ourselves a test environment. So how do we go about doing that? It's quite common in most languages to have a tests directory, and where we would define all of our tests. So this is our infrastructure modules. We have a test directory. We're testing the multi-cloud platform, which is what we call it module. We've got a unit test directory, and we're going to test Cloud Run adapter. So to get that logic, it's just simply a case of creating a symbolic link to the real file where the real logic actually lives. And then next to that symlink, in our test directory, we have another Terraform file where we declare our tests. And to do so, we need an external data source and an output which prints the results of that external data source. So as you can see here, our query attribute does a little loop itself. And this is an unfortunate circumstance that the query attribute needs to have a flat map of strings. It would be really nice if we could just feed the data straight into it, so we're actually testing, we're not doing any manipulation as part of the test. And maybe someone from HashiCorp can get that in as a feature request. It'd be really nice, particularly from our perspective, to not have to modify things like that. So the external data source then passes the value that's assigned to the query attribute to our test script, which is called test policy members.py. You can work out it's a Python script. We've kept the naming consistent all the way through, and that's where we define what our test should match up to. And this is the test case. It's just a Python script, as I mentioned, but there's nothing really much going on. We set up our test environment, which is importing our fixtures, our Python validator. we always put a description of what's going on in the test. And this is where we declare what the expected data is likely to be once it's being processed. We pass that expected data onto the Python validator, which is where all the magic happens. Well, probably not magic, just another Python script. So this is a Python script that we've passed our query data, our query values to, and pretty much all it's doing is checking that value in the query attribute, which has gone through our logic and our code and processed map what we expect it to. If it does, it's set the result to pass, which gets printed to standard out, one of the requirements for the external data source. And if it doesn't, it sets it to a fail, but along with it, it says what was expected and what was received. Let me just touch briefly on the highlighted lines that have the breakpoints in the margin, so validate and error. For brevity, I just left those functions out of the slide because they just check the type and make sure that errors are correctly formatted to Terraform. There's a link at the end to all this in the presentation, so if you want to go and have a look at them, you can do so from there. Next, we initialize Terraform. So we're in our tests directory. We do a Terraform init, and then we do a Terraform apply. And as you can see here, the output printed our result. We had 4 tests for this particular adapter of our module that we've got, and they all passed, which is nice. Our implementation particularly looks for test data values configured in files. Remember, we were looking for a YAML file, so we put a variables file next to it where we point to a resources directory where we contain all of our test data for our tests, but it can be quite easily passed in through a var file argument to Terraform apply. And that pretty much sums up the unit tests themselves. There's not a lot to it. It's pretty straightforward. But one of the things that I mentioned earlier was it would be one of the cool things that we can do with this once we have it is we can automate all those tests. So there's a couple of links here to our GitHub action workflows, one for unit tests and one for doing our integration tests, so doing some test deployments themselves. So we'll go and have a look at them. Okay, so please let me know if that's not big enough. Hopefully it should be. So as I mentioned, this is our GitHub action workflow. We're going to kick off this action based on pull requests into 2 branches. Also, if we see any pushes to those particular branches, and then we get into our jobs for our unit tests, we only want to run this if we've got particular labels on there just to prevent things running unnecessarily. And we have a setup of our working directory. So we're setting up our environment with our GitHub action. We sort out our dependencies. So we get the GitHub Actions runner. We get our Python version. We get our Terraform. And then we get into running our unit tests. So this is where the magic happens. First of all, we go looking for that main.tf from our unit test directory, set a variable, which is going to be the name that we'll use in our output. And then we're onto what we did in our slides. So Terraform init, Terraform apply, and that gives us access to the Terraform output, which we push through JSON so we can pass it nice and easily, where we're looking then to print the test and print the result. And if it's not a pass, we also include the expected and received data, which touched on earlier, and we mark it as an exit code 3, which sets the status of our particular run, our particular job. We can have a look at an example of one of those over in our actions until our unit tests. And we've got our checkout of our code. We've got set up our Terraform, and we have now the run of our unit tests. We've got a little drop down here where we can see that little bit of code that's in the particular job. and we get a nice output of printed passes, and this one all passed. Next, we had our integration tests. So let's zoom in again. Similar sort of setup, but we're only running these when we see pushes to specific branches. We've got our setup again. Now, the differences here is that we're actually needed a real environment to deploy to, and we're deploying to Google Cloud. So we create transient projects on the fly in an isolated, protected folder on Google Cloud, where we can run our tests and we can track it for various different things like costing and security and all those good things. We give it a name based off the SHA reference and the GitHub run number. And then we get into setting up our environment again, sorting out our dependencies. In this particular case, we need Cloud SDK, so we can set up Google Cloud. We create ourselves a project. We enable all of the APIs that we need to perform our testing. We need a service account that can actually do any of those deployments. And then because we've got our transient project, which has a different project ID every time, we just need to set that into our test data. So that's what's going on here and here. One of the things that we're doing is a module around Kubernetes deployments. So we get ourselves a GKE cluster. And then we get into testing against Kubernetes. So we'll do a real deployment using that module, which is in our MCP module. We'll do a plan, we'll do an apply. That all works. This particular step is a pass, and we'll destroy it. Then we move on to other aspects of Google Cloud Services. So two of those being Cloud Run and Google App Engine. And to do that, we need an image in the artifact repository. So we go and put one there, it's just a hello world. We put the URL again, because it's into our configuration, input values for our tests. And then we do the same thing against GCP. And we can have a look at one of those actions over here, deployment tests. These are our deployment tests. We're in here. We'll go through all the setup bits just because of time. Here we've got deploy Kubernetes, and we can see here there's a whole load of resources that are being deployed to GKE, quite a lot. So it's a good test case. All the way down, yeah, very long, and destroy. And then the same thing happens on Google Cloud. So we can have a quick look at the test data. I've got to get all the way to the top of that screen now. Test directory. So we have MCP deployment Kubernetes. Here's our Kubernetes file, and here's our definition for all of our test data. Okay, so that pretty much wraps it all up. There's some links here to the description of what we do and how we've implemented the tests on the tests README. There's a credit here because that Python validator was actually something we found online. We've adapted it a little bit, but all credits due to that person whose name, unfortunately, I'm sorry, I've forgotten. And some other links here. So if you want to discuss anything in a bit more detail, or if you've got any pressing requirements in the cloud or DevOps space, we're always interested to help out. So please get in touch in one of these links. And that's it. Thank you.
All right, thank you very much. I'll, like a little bit of applause. Normally I would ask people to come off mute and then do a little round of applause, but it's not possible today. Thank you, that was really useful. It's like I've been speaking to many customers. They've all been like, oh, well, how do I do this? So how do I like structure modules and do testing stuff? This has just been quite useful. And I'm assuming that most of the people on the, the other people will have found it useful as well. There actually have been a few questions, and we do have some time left, so I'll ask you them in person. Michael Hanley wanted to know if these tests can also be done on a Vagrant box.
Yeah, so we also use Team City as well for running those tests. The on one of the slides there was just a very simple run that I did that just printed out on my Mac. We run them on Linux machines, so yeah, pretty much anywhere really, anywhere that's got Python and Terraform installed. So you have a look at the workflow itself and see what dependencies that we set up, and yeah, you could run it anywhere.
All right, excellent. Thank you. I'm assuming that will answer his question. And there are some other questions from Fernanda Martins. They want to know, just so they understand, unit testing is actually validating a YAML, which is your input. Do you need to have some sort of established format for that input? Is that correct? I'm not entirely sure if I understand that question myself.
I think I know what they were referring to. Yeah. So it's not exactly a test of the YAML itself. It's a test that when we receive a YAML, that we can process that and get it into a map or a list or whatever it is that we need, that is then going to be applied to resources later on. This is just a very specific use case, but I used it because it gives a really good example of quite a complex case, really. And yeah, in that MCP, which is what we call our multi-cloud platform modules, there's a few other different apps that we've got going on around being able to deploy to multiple clouds easily. And we have defined what we called an MMCF, Mesoform multi-cloud configuration format.
All the acronyms.
Really, it's just yeah, I know. It's really just taking whenever there's configuration for those services, we take that YAML and we just import it and kind of wrap it a little bit with a few extra features. But like I said earlier on, the purpose of it is to keep that consistency as close as possible for developers that perhaps wouldn't want to have to go off and learn Terraform and other cases.
Yeah, exactly. And I'm assuming that obviously because of the high profile customers or like enterprises and government instances that you worked for, then the easier you can make something repeatable and secure and make sure that it works. It's
yeah.
You know,
yeah,
exactly.
I get that. There's those cases where we've got configuration from one place, we've got policies from another place, we've got the Terraform code from another place, and we're putting all that together and then deploying them. Taking responsibility to deploy that. Yeah.
It's interesting that all the customers that I speak to as well, like there seems to be such a common theme, and it's interesting to see that you see the same things too. So thank you again for that. Mm-hmm. Another point from Alexei, you were saying that he had no idea they can be tested at all. That was great. So that was just a little shout out. So thank you for that. Would you be able to put these links in the chat so people can check it out there on time?
Yeah, sure. Absolutely. Yeah.
Excellent. All right. Well, thank you again. I wish you a lovely day.
Which chat were we on about? The YouTube chat the YouTube or chat, the yes. Zoom chat?
No, the
Zoom
one on
chat,
YouTube.
Yeah, no problem.
No, the one, YouTube.
Okay.
YouTube, not Zoom.
YouTube.
Yes,
yeah.
Yes, YouTube. Hopefully we'll get some extra affiliate links for saying YouTube a couple of times in a row. No, I'm kidding. All right. Well, again, thank you. And until next time.
Yeah, great. Thank you very much.
No problem.